Welcome friends, welcome to this lecture series for your GATE 2027, and we are discussing some of the important topics for your GATE examination, and one of the important topics is the voids in a bituminous mix. There are several terms, we will see these terms and understand those terms. So this is voids in your bituminous mix, and regularly they ask questions on this. So we'll see the formulas and then I will also see that what kind of questions are asked in the GATE examination. So we'll see all these things: air voids, bitumen percentage, VMA, VFB. What are these things? We'll see all of them in this particular lecture. And then before starting, you can join this Telegram group for further notes and other lecture topics and guidance. Okay, let us start. So I am telling that voids in your bituminous mix. Voids in bituminous mix. Now what is a bituminous mix? In bituminous mix we have bitumen and aggregates and we have some filler. Okay, and we combine all of them to make a mix which is used in road construction. And bitumen acts as the binder, it binds all the constituents. So if I say the constituents of bituminous mix, the constituents will be what? They will be aggregates. They will be aggregates. Yes. Then there will be your bitumen. Bitumen. There is some filler. This filler is normally sand. Normally what? Sand. And then these aggregates can be coarse aggregate. Yes, they can be fine aggregate. In coarse also there can be different type of coarse, or there can be one type of coarse aggregate, there can be different type of coarse aggregate. Okay, and in fine also there can be one type of fine aggregate, or there might be some different types of fine aggregate depending on their specific gravity, Now voids in bituminous mix. So what happens is that if you are seeing this mix, there are aggregates, there are suppose coarse aggregates, and there are some small, fine aggregates, and then there is sand, very small, sand is very small, yes. So coarse aggregates, then there is fine aggregates, and there is sand is there, small. So what happens in between them, in between that space, there will be voids, right? Okay, there will be voids. Suppose just seeing, you can see this is the voids, right? There will be voids, but I'm not drawing the entire thing. There will be voids. Okay, the space between them, the space between the coarse aggregate, fine aggregate, and the filler or sand, there will be voids. So in these voids, you can see in these voids, the voids will be either occupied by air or it will be occupied by bitumen, right? So when in this coarse aggregate, fine aggregate, filler or sand, you are adding bitumen. So bitumen will not occupy the entire voids. The bitumen will not cover, or I can say occupy the entire voids. Some of the voids will be covered by the, or we can say they will be filled by the bitumen, and some of the voids will remain unfilled. And what will be there inside those voids? Inside those voids, air will be there. Inside those voids, what will be there? There will be air. So when I am saying that inside those voids, there will be air, so I can say these voids can be classified into what? One is air voids, and then we have bitumen voids, or I can say the voids which is filled with bitumen. Okay, so this is air voids and this is bitumen voids, or I can simply bitumen also I can say. Now this total voids, which is a combination of air voids and bitumen voids, this will be known as what? VMA. That is voids in mineral aggregate. Known as what? Voids in mineral aggregate, or I will say VMA, or I can say what? VMA. So total voids, I can say that air voids and bitumen voids, total voids will be called as what? VMA. VMA, total voids. Now From air voids, I get a term known as what? Percentage air voids. This is known as what? Percentage air voids. This is known as what? Your percentage air voids, VV. And this is what? This is, I can say, this is the volume of air voids, or I can say volume of air simply, volume of air divided by total volume, not only the volume of voids, total volume means total volume into 100. This is known as what? The percentage air voids. Then we have percentage bitumen. This is VV, that is air voids, or sometimes they write VA also. And here it is percentage bitumen. This is percentage bitumen, and this percentage bitumen is equal to what? The volume of bitumen. This will be equal to the volume of bitumen divided by total volume, divided by what? Total volume into 100. Okay. So we have two terms. One is the percentage air voids, then we have the percentage bitumen. And percentage air voids is what? It is the volume of air by total volume into 100. And percentage bitumen is what? Volume of bitumen by total volume into 100. So denominator is same, which is total volume. This is volume of air, this is volume of bitumen. Now how we calculate this percentage air voids? Okay, how we calculate this percentage air voids? For that we see two specific gravities first. So what are the two specific gravities? The first one is theoretical specific gravity, or this is also known as maximum theoretical specific gravity of the mix. Is the maximum theoretical specific gravity of mix. Of the mix means bituminous mix. And how we calculate this? This is very simple. This we calculate by doing the summation of all the masses divided by the summation of mass by specific gravity of each constituent. Okay. See, we have different constituents. Like we have coarse aggregate, fine aggregate, filler, bitumen. In coarse aggregate also we can have different type of coarse aggregates. We can have different type of fine aggregate. Yes. And we have bitumen. So if we add all the masses, this is known as what? Sum of all the masses. And here what? The sum of the ratio of mass and specific gravity. Yes. And you see, all these different constituents will have different masses. They will have different specific gravity also. You see, coarse aggregate will have different specific gravity than fine aggregate, and then they will have different specific gravity from the filler or sand. They will have different specific gravity of the bitumen. Yes. So if you do this summation of mass, denominator is what? Numerator is what? Summation of mass, and denominator is summation of mass by specific gravity. Then I will get what? The maximum theoretical specific gravity of mix. Okay, very good, very nice. Then we have GM. This is the actual specific gravity or the bulk specific gravity. Now see, what is the difference between this bulk specific gravity or the actual one? This is the actual one. This is the correct one. This is the wrong one. This is the correct one. And this is the wrong one or the theoretical one. What's the difference? You see, the difference is that the bulk specific gravity here, we are considering the volume of air. Means, see, when you prepare the mix and then when you take it to the field, you compact the bituminous mix, right? So what will happen when you compact the bituminous mix? The air voids will reduce. Yes, but it will not become zero, right? It will not become zero. But if theoretically you make it zero, okay, and then you find out the specific gravity, that is known as what? The maximum theoretical specific gravity. So this maximum theoretical specific gravity, this we have got assuming what? Your zero voids, zero air voids. This, or by ignoring, I can say zero air voids, or I can say by ignoring the volume of air. So this is the maximum one, means what? Theoretically, why theoretically? Because I am saying that I will compact in such a way that there will be no air voids. It's a theoretical thing, right? But practically it will never happen. Practically some air voids will always remain, right? Practically some air voids will always remain. And therefore, this is the actual one of the bulk specific gravity. Yes, and how we find out this bulk specific gravity? You see, this is the mix. This is the mix. This is the mix. Okay, this is the mix where we have all the constituents, coarse aggregate, fine aggregate, filler, and then bitumen, everything is there here. So from this mix, we'll take a small portion and we'll prepare a sample. We'll prepare a sample. We'll prepare a sample or specimen, I can say. We'll prepare a sample or a specimen. Then what I will do, I will take the mass of this sample and then I'll divide it by the volume of the sample. I'll divide it by the volume of the sample. So this will give me what? The actual specific gravity. And why to give me the actual specific gravity? You see, when from the mix, we have prepared this sample. In this sample, there will be air also, na? Because in the sample you would not have compacted to 0 air voids, right? So in this sample there will be some air. So in this sample there will be some air. So I can say in this volume of the sample there will be some air. So this is the actual specific gravity or the bulk specific gravity. This is the theoretical one, the maximum theoretical specific gravity of mix. So you can calculate both of them, and from both of them I can find out the percentage air voids. Very simple. It is equal to 1 minus Gm by Gth into 100. By using this formula, I can find out the percentage air voids. Very simple, right? I find out this, the maximum theoretical specific gravity, okay, and then the bulk specific gravity of the mix, okay, by preparing a sample and then taking the mass of sample and volume of sample. Yes, and from here I can find out what? The percentage air voids. The percentage air voids. Now, how to find out the percentage bitumen? Very easy. The formula is, we'll take the mass of the bitumen. You see here, in this mix, there will be the mix will have different constituents, and in that I'll take the mass of the bitumen divided by what? The total mass of the mix. So here I will take what? This MB is what? Mass of bitumen. This is the mass of bitumen, and then MB is what? M is the total mass of mix. All this information will be given to you. We'll solve a question to understand also. Total mass of mix, and then here you will divide it by the specific gravity of the bitumen, and then here the specific gravity of the mix. And I will take here Gm. Why? Because Gm is the actual specific gravity. Yes, and then into 100. This will give me the bitumen percentage. Okay, this will give me the bitumen percentage. Or I can say the bitumen void percentage, because the bitumen will be in some void site. Yes. And now, as I told, what is VMA? The total voids in mineral aggregates. That is simply what? The air voids plus the bitumen. That will give me what? The total voids. This is VMA, total voids, or I can say voids in mineral aggregate. I can say the voids in mineral aggregate. Then we'll come to the last term, that is VFB, voids filled with bitumen. Voids filled with bitumen. We'll come to the last term, that is voids filled with bitumen. This is what? This is very easy. This is the bitumen volume, or I can say volume of bitumen. The volume of bitumen divided by what? The total volume of voids. Total volume of voids into 100. Now see, volume of bitumen is how much? This we have calculated. This VB, this is the volume of bitumen, right? Divided by total voids is what? Total volume of voids is what? It is VMA, right? So simply VB divided by VMA into 100 will give me what? VFB. These are the formulas, were very important formulas which they repeatedly ask in the GATE exam. Let us solve a few questions on them. So I'll solve 2 questions and then 1 question will be your homework. So you see here, First of all, we can find out theoretical specific gravity using this formula. Then we prepare a sample and then find out the actual specific gravity or bulk specific gravity. Air birds we calculate using this 1 minus gm by gth into 100, and then this is the percentage air bird, this is the percentage bitumen, right? This is the percentage bitumen. Then we have what? Then VMA, total voids. We'll add the air voids and bitumen. Then we have voids filled with bitumen. That will be the volume of voids by total voids into 100. Very easy. Let us solve one question. You can see here, you see. So you see in this question what is given? The different aggregates are given. Aggregate 1, 2, 3, some will be core, some will be fine, but they're just given 1, 2, 3, okay. Their masses are given and the specific gravities are given. Filler or sand mass is given, the specific gravity is also given. Bitumen mass is given and specific gravity is given. Now from this mix, we will prepare a sample that is known as what? Marshall sample, because Marshall derived all this formula. So this is known as Marshall mix design or the Marshall method of finding out all the voids. So the sample is mass is 1100 and volume is 463. So from this we have to find out voids filled with bitumen. Means we have to find out what? VFB. So to find out VFB, I need many things. Let us find all of them one by one. Let us find them all of them one by one. Now first of all you have to find out what? The G theoretical or the maximum theoretical specific gravity. How we get this? We'll take the summation of mass, right? Divided by what? Summation of mass by G, right? Now see, this is mass, this is G. I can have a thing called what? Mass by G also, a column of what? Let me have a column of mass by G also. Let me have a column of mass by G. So this is mass, this is G, and suppose this column is mass by G. Let me find out mass by G. So 530 divided by 2.72. We're getting a value of, you see, 194.85. The next is 410 divided by 2.62. This I am getting as 156.49. Next is 670 divided by 2.65. I am getting a value of 252.83. Then we have 290 divided by 2.53. I am getting 114.62. But last 100 divided by 1.02. I am getting a value of 98.04. So just, you know, what we will do is we just find out all these values. Let me just cross check this. Let me just cross. It's always good to cross check the values because we might have done some calculation mistake. Let me just cross check these values. Okay. Yeah, these are the values. So now you see summation of mass. Summation of mass means what? We'll add all these masses. So 530 plus 410 plus 670 plus 290 plus 100. The sum of mass I am getting is 2000. This is the sum of mass. The sum of mass of all the different constituents. Then we have what? The summation of mass by specific gravity. So this I am getting how much? Let me add this 194.85 plus 156.49 plus 252.83 plus 114.62 plus 98.04. This I am getting is 816.83. This is the summation of what? Mass by specific gravity. Summation of mass by specific gravity. So I can put now in this formula. So what I will get, you see, summation of mass is 2000 and then summation of mass by specific gravity is 816.83. We calculate this value. I am getting a value of approximately, if I round to 3 decimal place, I am getting 2.449 approximately. I can do a rounding up. Okay, I can do a rounding up. Let me just cross check these values. Almost I am getting this value. Okay, so this is the theoretical maximum specific gravity I am getting is 2.449. Then what I can do is I can do this from the sample. Mass is given and the volume is given. So what I can do, I can find out the actual specific gravity of the mass or the bulk specific gravity, how much? The mass of the sample divided by the volume of the sample. So how much I am getting? This is 1100 divided by 463. I am getting a value of 2.376. I am getting a value of 2.376. So now I can find out the percentage air voids. How? You see, I got GM 2.376. I got GTH, that is 2.449. So next what I can do is, I can find out the percentage air voids H 1 minus GM by GTH into 100. So how much will get this value? This is 1 minus 2.376 divided by 2.449 into 100. So what is the percentage air voids? If you calculate this 2.376 divided by 2.449, 1 minus answer into 100, I am getting a value of approximately 2.98 percentage. Let me just cross check this value once. 2.376 divided by 2.449. Okay, just cross check these values, that because you see when such calculations are involved, so always have a cross check. Okay, 2.449. So okay, 2.98. Actually, let me take this as 2.448. It is more actually 8. See, that is, you will get a minor variation. You will get a minor variation, but let me take it 8. Okay, get a minor variation. We will get it 2.94. Get 2.94 actually. So let me take it 2.94. Okay, because if we do some rounding up, we'll get some 2.448 actually. More accurate is 2.448. Okay, so I got this percentage air voids. So I got the air voids. Now if I want to find out the percentage bitumen, what is the formula? It is the mass of bitumen by total mass into the specific gravity of the mix, GM, by specific gravity of the bitumen into 100. Now mass of bitumen is how much? It is given 100, right? You see the mass of bitumen is given 100. Total mass is how much? 2000. Okay. So 100 by 2000. See, here we take the total mass of the mix, not of sample. Okay. Into GM we just got 2.376 and specific gravity of bitumen is given as 1.02. It is given how much? 1.02. So into 100. So how much we will get this value? You see, this is, if I calculate this, 100 divided by 2000 into 2.376 divided by 1.02 into 100, I'm getting a value of 11.65% approximately. So this is the percentage bitumen you are getting. So we got our air voids, we also got our percentage bitumen, right? Now I can easily find out what? The total voids. You see, this much is air, this much is air, and this much is bitumen. So total void is what? VMA. VMA is what? It is 2 air voids plus bitumen voids. This is 2.94 plus 11.65. I'm getting approximately 14.6 or 14.59 percentage. So we got the air voids, we got the bitumen, and then we got the total voids. Now what is asked? Question asked is voids filled with bitumen. Now voids filled with bitumen is what? It is volume of bitumen by total voids into 100. So volume of bitumen we got how much? 11.65. Total voids we got how much? We got 14.59 into 100. So how much we'll get? We'll get a value of 11.65 divided by 14.59 into 100. I'm getting approximately, you see, 79.85%. So this is the VFB. So if they ask you air voids, we'll solve in this manner. If they ask you the percentage bitumen, then we'll solve in this manner. If they ask you to find out total voids, we'll solve in this manner. It means, see, total, see, once you get the air voids, you get the bitumen voids, you have to just add both of them. If you add both of them, you will get the total voids. And if you want to find out the voids filled with bitumen, then what you will do? You will just take the volume of bitumen by total voids into 100. So this question, actually in this question, this is not a single question. There's many questions, you see. See, here we solved the theoretical specific gravity also, right? We found out, they can ask you to find out the theoretical specific gravity. They can ask you to find out the actual specific gravity or the bulk specific gravity. They can ask you to find out the air voids. They can ask you to find out the percentage bitumen. They can ask you to find out total voids. They can ask you to find out the voids filled with bitumen. So in single question, we actually solved 5-6 questions, right? Now this question we solved. Now one question homework for you. Okay, one question homework for you. The homework question is this one. You see here, during the determination of bulk specific gravity of a mixed specimen or sample, the mass of the sample is given, or specimen means what? Sample, and the volume of the specimen or sample is given. Now, the maximum theoretical specific gravity is given, GTH is given. Now they have asked you to find out the percentage air voids. They have asked you to find out the percentage air voids. So please solve this question and mention the answer in the comment section. Mention the answer in the comment section. Okay. So is the homework question. So one question I solved for you. Yes. One question I solved for you, and one question is homework for you. So it's very easy question actually. Actually, similar question was asked in GATE. So they ask you such easy questions only. So please solve this question and mention the answer in the comment section. And as I told you, please join this Telegram group, because in Telegram group I will be providing more. In the Telegram group, we'll find out lot of lectures, and we'll find out a lot of short notes related to your GATE examination. Lot of guidance also provided for the GATE examination. Yes. Okay. That's it. So thank you very much. See you in the next lecture. But before that, we'll summarize. So we saw, first of all, we saw G theoretical, and G theoretical is what? It is summation of mass by specific gravity of different constituents. Then we prepared a sample from the mix, and the actual specific gravity or the bulk specific gravity is the mass of the sample divided by what? The volume of the sample. Then we got the percentage air voids. How to calculate the percentage air void? It is 1 minus Gm by Gth into 100, right? 1 minus Gm by Gth into 100. And then the percentage bitumen is what? It is the mass of bitumen by total mass, then specific gravity of mix by the specific gravity of bitumen into 100. Okay, so this is air void, this is bitumen voids. Now total voids, VMA is what? It is air voids plus bitumen voids. And then voids filled with bitumen is what? It is volume of bitumen by total void. So VMA into 100. So all these formulas, we solved one question, and then one question I gave you homework. Please solve that question and mention the answer in the comment section. Mention the answer in the comment section. Thank you very much. See you in the next lecture, and we'll see some other important topic for your GATE examination. Thank you.